All right, we're going to go ahead and do some approximations of radians to degrees. And we're going to pick out some basic ones, 30 degrees, 45 degrees, 210, and 315. So the first thing I want to go ahead and just remind the group is that when we're talking about radians, we know that we have 2 pi radians that go all the way around the circle. And in a previous video, we went ahead and showed that if we want to go ahead and look at that, we can actually turn on all of the radians because 1 radian is equal to the length of 1 radius. And we can count them as we go around the circle. And you can see that there is approximately 1, 2, 3, 4, 5, 6, and a little extra change. And that little extra change comes from 2 pi being 6.28. So there's about 28% of the extra one. Now the question is, well, how many radians is 30 degrees? So when we think about this, we want to break it down into its components. I know that there's 2 pi in 360 degrees. So I also know that if I come over here to 180 degrees, that breaks that 2 pi in half, giving us 1 pi, okay? Now I've got 180 degrees, which is going to be pi. And what I want to know is how many does 30 degrees go in? And 30 degrees is roughly right over here. So it's actually just a little bit less than 1 full radian, okay? Well, what I could do is I can do some math and I can say, well, I know that 60 is roughly here. 90 is roughly here. 120 is roughly there. 150 is right there. And check it out. I know that 180 goes right there. So essentially, if you notice, there are 1, 2, 3, 4, 5, 6 times that 30 goes into 180 degrees, okay? Or in other words, if 30 goes into 180 degrees 6 times, it also divides pi into 6 pieces. So 30 is pi divided by 6, because we've taken half of the circle and we've looked for 1 out of these 6 pieces that are there between 0 and 180 degrees. Well, now let's go to 45 degrees, okay? And we'll go with that same mentality there. If I go to 45 degrees, okay, let's go ahead and put that. I'm going to leave pi as 180 degrees because I like to use that as my base. If I go to 45 degrees, that roughly cuts that 90 right in half. So let's go ahead and sketch that. There's 45 degrees. Well, just like the last one, I can break it in. 45 plus 45 is 90. There's another 45 degrees. And then we come out here, there's another 45 degrees. There's 2 for every one of them. And then there's another 45 degrees. So 45 plus 45 plus 45 plus 45 is going to give us 180. Well, if we go back to the fact that 180 is pi radians, well, 45 is only 1 out of those 4 pieces. So there's 1, 2, 3, 4 45s in there. So what we're going to do is we're going to say pi divided by 4 because it's only 1/4. Well, how can we do that easier? Well, I know that 180 divided by 45 is 4. And that tells me there's 4 equal pieces and we only want 1 of them. So I just put 1 pi over 4. Well, now let's go to 210. Let's see how we work on something like 210, okay? 210 works a little bit different, okay? Because it's past the 180 degree mark. So if I come over here and we look at 210, there's 180, and then we go a little bit more, and that brings us to 210. Well, how much more? Well, if I take 210, I subtract it 180 from it, that's going to leave me with 30 degrees. Okay, so I say, oh, there's 30 degrees more. Well, we already know about the 30 degrees. We know that 1 30-degree piece, okay, so we know a 1 30-degree piece is equal to pi over 6. My question is, how many 30 degrees pieces are there in order to get to 210? Let's see if we can do that. Well, I know that there's the 60, there's the 90, there was the 120, there was the 150, there's the 180, and then another 30 degrees brings me to here, 30, 60, 90, 120, 150, 180, and 210 is another 30. Well, how many are there? There's 1, 2, 3, 4, 5, 6, 7 of them. So 7, it took us 7 30-degree pieces. So 30 degrees is pi over 6. So pi over 6, and it took 7 of them. So I just say there are 7 pi's over 6 is going to be the amount of radians, okay? Now, if we wanted to check that, we can actually do this nice and easy, because some people right now are probably going, well, that doesn't make any sense. That looks a little bit funky. Well, we can check that, and we can come back and say, well, what is 7 pi over 6? Well, 7 pi over 6 is 3.66 radians. And if we count them out, we have 1, 2, 3, 4, but we said 120 degrees was right at about here. So that is 1, 2, 3, and part of the fourth, 3 and some change. And there's our change, 0.66, okay? Now let's try 315. Okay, let's go ahead and try 315. Well, right now I'm thinking to myself, well, how in the world can I figure out 315 degrees? Well, let's go ahead and look at some of our fractions again, because we're using some basic stuff right now, okay? So I go to 315, and 315 is somewhere right around here. This is 360, this is 270, so 315 is probably somewhere right around here. Okay, well, let's see here. How far past 270 is 315? So 315 minus 270, looks like that's about 45 degrees. Okay, so let's try our 45-degree piece. Okay, so let's go back here. And let's go ahead and go back to 45 degrees because we have that. It is pi over 4. Okay, so 45 degrees is pi over 4. Let's go ahead and keep working with it. So there was 90. Okay, there's 135. Okay, 45 plus 90 is 135. This is 180. 135 plus 45 is 180. Another 45 brings us to 225 degrees. Another 45, 225 plus 45 brings us to 270. And another 45, 275 brings us to 315. So what we know is, let's go ahead and count that out now. There's our 45. And in order to get to 315, that is 1, 2, 3, 4, 5, 6, 7. So that is 7, but it is 7 pi's over 4. Now let's check with our picture to make sure that makes sense. So let's go ahead and put 7 pi over 4. You'll notice that it is 5.49. So let's go ahead and count our radians. So we have 1 radian, 2 radians, 3 radians, 4 radians, 5 radians, and then some change, about cutting it in half, actually. Okay, so it about cuts it in half. So 7 pi over 4 makes sense. The other thing we can do is we can go ahead and change the decimal out. 7 pi over 4 is the same thing as 5.49, but check it out. We know 1 radian is 57.3 degrees. Okay, so we can go ahead and say, well, let's take 315 and divide it by 57.3 degrees. And notice what happens. We get 5.497 radians, which is exactly the same as what we have with the fractions of a circle.